All right, last section we're going to talk about is sum and difference formulas. So what if you're given an angle like 75 degrees, which actually we're going to talk about in a second, that is not on your unit circle. Without using your calculator, can you find the exact value of that cosine or sine or tangent value? So oftentimes if we can break it down into the sum of 30 plus 45, or if we can subtract or something like that, then we're able to find the exact value. So these formulas are pretty long and pretty complicated. So obviously you're not going to have to memorize them, but you should know how to apply them, okay? So find the exact value of cosine of 75. So we have to be able to break this down into either two angles that we can add that we know how to find, or two angles that we can subtract that we know how to find. So I'm going to break 75 down into 45 and 30. Okay, and obviously I'm adding those two numbers. So cosine of 45 plus 30. Okay, all right, so therefore I'm going to use this first formula here, cosine of A plus B. So that means it's going to be cosine of A, cosine of B, minus sine of A, sine of B. Okay, it doesn't matter which one you call A, which one you call B, but keep it consistent. All right, so here we go. So we'll call this one A and this one B. So it's going to be cosine of 45, cosine of 30, minus sine of 45, sine of 30. All right. So if I look at my unit circle, what is the cosine of 45 degrees? That's going to be square root of 2 over 2. What is the cosine of 30 degrees? That's going to be right here, and that's square root of 3 over 2. Minus sine of 45 degrees, square root of 2 over 2. Sine of 30 degrees, 1/2. All right, so then we just have to multiply these. So square root of 2 over 2 times square root of 3 over 2 is square root of 6 over 4 minus square root of 2 over 4. So that gives me square root of 6 minus square root of 2 all over 4. And that's your final answer. Can't simplify that at all. All right, next I'm given one in radians, so pi over 12. So I have to think about how I can break that up. So think about it as like 1/12. So this one's obviously going to have to be a subtraction one. So I'm going to think about it as 4/12 minus 3/12. Well, 4/12 is just 1/3, and 3/12 is 1/4. So I'm going to be using the same angles, pi over 3 and pi over 4, but this time I'm subtracting with them. So this time my formula is going to be cosine of A, cosine of B, plus sine of A, sine of B. Okay. Now you can probably predict what's going to happen here, but let's just go ahead and go through the algebra. So we have one angle that's going to be pi over 3, and one angle that's going to be pi over 4. All right, so cosine of pi over 3, wait, hold on, I messed this up right here. Okay, let's back this up. So cosine of 4/12 minus 3/12. So cosine of 4/12, which is pi over 3, okay, minus pi over 4. So it's not the same angles, but very similar. Okay, there we go. So cosine of pi over 3 is right here. So that's going to be 1/2. Cosine of B, which is pi over 4, is square root of 2 over 2. Plus sine of A, which is pi over 3, is square root of 2 over 2. Sorry, square root of 3 over 2. What am I doing? Okay, sine of pi over 3 is square root of 3 over 2, and sine of pi over 4 is square root of 2 over 2. All right, now we can simplify this. So when I multiply these two, I get square root of 2 over 4 plus square root of 6 over 4, and just adding this together, there we go. Okay. So another one, very similar. This one's 7/12, so I can break that up into 3/12 and 4/12. Okay. 3/12 is the same as 1/4. 4/12 is the same as 1/3. So pi over 3 plus pi, pi over 4 plus pi over 3, or pi over 3 plus pi over 4, same thing. So sine, okay, so sine being added, okay, so therefore my formula for that is going to be a sine of pi over 3 cosine of pi over 4 plus, okay, so notice sine when you're adding, there's an adding in the middle, and cosine when you're adding, there's subtracting in the middle. A little bit confusing there. All right, plus cosine of pi over 3 sine of pi over 4. All right, so sine of pi over 3, go back up here. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2. Cosine of pi over 3 is 1/2. And sine of pi over 4 is square root of 2 over 2. All right, so then I get square root of 6 over 4 plus square root of 2 over 4. So that's square root of 6 plus square root of 2 over 4. And notice that's the exact same answer as what you got for the last one. So you're going to be dealing with a lot of the same numbers. All right, this one right here is going to be pretty simple if you can recognize the formula, so you're not going to have to do any math. So first of all, I recognize that it's a sine because I start with sine here, okay? And then I notice that it's subtraction in the middle, okay? So therefore, I'm going to do sine of 80 minus 20. So that's sine of 60. So I know how to find the sine of 60 degrees because that's on my unit circle. So that's 1/2 square root of 3 over 2. Sine is my y value. So therefore, it's going to be square root of 3 over 2. Okay, so in that one, it broke it up and you had to recognize and go backwards to the formula. Okay. I'm probably not going to give you a tangent one just because of all of this. So don't really worry about the tangent, just worry about sine and cosine. Okay. I do want to do this next example though. All right, so I'm given sine of A, which is 4/5, and I'm told it's between pi over 2 and pi. So let's sketch that out first. So between pi over 2 and pi, and sine of A equals 4/5. So opposite over hypotenuse. Okay. Now you can recognize, I'm not going to go through Pythagorean theorem here because you should know if this is a right triangle, this is a 3, 4, 5 triangle. However, that 3 is going to be negative because I'm going to the left. Okay. But if you didn't know that, use Pythagorean theorem, get your third side. All right, now let's draw our second triangle for B, or beta in this case, between pi and 3 pi over 2. So that's going to be in my third quadrant. And it says sine is negative 2 over square root 5. Okay, so opposite over hypotenuse. Okay, so I am going to use Pythagorean theorem here. So negative 2 squared plus x squared equals square root of 5 squared. So 4 plus x squared equals 5. All right, so x is going to equal negative 1. And again, that's negative because I'm going to the left. All right, so it asked me to find some different things. So in part A, it just wants cosine of A. So adjacent over hypotenuse, it's going to be negative 3 over 5. Cosine of B, so adjacent, label B there, adjacent over hypotenuse, so that's going to be negative 1 over square root of 5, or negative square root of 5 over 5. All right, this one, the next two we're going to have to use some formulas for, so cosine of A plus B. So on this one, you can't just add those together. Remember, you have to use your formula, so that's going to be cosine of A, cosine of B, minus sine of A, sine of B. Okay. All right, so cosine of A is negative 3/5. Cosine of B, we said, was negative square root 5 over 5. Minus sine of A, they give you, is 4/5. And sine of B is negative 2 square root 5 over 5. And I'm just using all the ones with the 5s on the bottom just to make my multiplication a little bit easier. All right, so now I have negative times a negative, so that will give me 3 square root 5 over 25. And then positive, so plus 8 square root 5 over 25 equals 11 square root 5 over 25. Okay. All right, last one is D, so same concept but different formula. Okay, so sine of A plus B. So here it's going to be sine of A cosine of B minus cosine of A sine of B. All right, so sine of A was 4/5. Cosine of B, negative square root 5 over 5 minus cosine of A, which is negative 3/5, and sine of B, negative 2 square root 5 over 5. All right, so here I get negative 4 square root 5 over 25. And then negative times a negative is a positive, but I am subtracting it. So here I get minus, minus 6 square root 5 over 25. So that would give me negative 10 square root 5 over 25. Okay. All right, next page. All right, a couple identities with adding and subtracting. All right, so cosine of A minus B. So I can break that up into cosine of A, cosine of B, plus sine of A, sine of B, over sine of A, sine of B. Remember, still only manipulating one side of your identity. All right, so let's break this up. Cosine of A, actually, I'm not going to write all that out. All right, let's recognize something. I can break this up into two parts, the left side and the right side. Now, the right side is just going to equal 1 because sine of A, sine of B over sine of A, sine of B is just 1. So I'm really going to be talking about cosine of A, cosine of B over sine of A, sine of B plus 1. All right, so in both cases, I have cosine over sine. That's just going to be cotangent of A, cotangent of B, plus 1. And that's the same thing as what I have on the right side. So I check it off. All right, next one. So tangent of theta plus pi. All right, so I am going to go ahead in this one. I know I said not to focus on tangent, but in this one, you should just be able to use the identity that's given, or use the formula that's given to you. So tangent of theta plus pi, so we can break that up just using the formula. So the formula is tangent of A plus tangent of B, 1 minus tangent of A, tangent of B. Identities with tangent aren't too bad. It gets pretty messy when you do the algebra with it. All right, so let's just plug stuff in. So this turns into tangent of theta plus tangent of pi over 1 minus tangent of theta, tangent of pi. All right, so tangent, this should be pi right here. Okay, so tangent of pi is 0 over 1, which is just 0. So that's going to turn into this just being 0, and then tangent of pi, this just being 0. Okay, so some nice things start to happen. Okay, so I end up with tangent of theta over 1, which just equals tangent of theta, which on the right side also equals tangent of theta, and therefore I've proved my identity. Okay. All right. Let's do one last one here. Let's just do this top one. So tangent of theta plus pi over 2. All right, we could split this up with a tangent identity, or we could do this with sine and cosine. Let's do it with sine and cosine. All right, so tangent of theta plus pi over 2. So I can rewrite this as sine of theta plus pi over 2 over cosine of theta plus pi over 2. So now I have a sine sum and then a cosine sum on the bottom. Okay, so I'm going to have to split up the sine sum and then the cosine sum. All right, so the sine is going to turn into sine of theta, cosine of pi over 2, plus cosine of theta, ooh, that's not a theta, theta, sine of pi over 2. And on the bottom, I have cosine of theta, cosine of pi over 2, minus sine of theta, sine of pi over 2. All right, so let's look at pi over 2, because that's the angle I'm talking about here. So that's 0, 1 on my unit circle. So the cosine value of that is 0. Okay, the cosine value of that is 0. So that means this is going to cross out, this is going to cross out because I'm multiplying by 0. And that means this is going to cross out and this is going to cross out because I'm multiplying by 0. Now, this guy right here equals 1. This guy right here equals 1. Okay, so I'm going to end up with cosine of theta over negative sine of theta. Okay, because this is just times 1. All right, so cosine over sine is cotangent, but it's negative. So that equals negative cotangent of theta on the left, which equals negative cotangent of theta on the right. And therefore, that matches, and therefore we've proved our identity. Okay? All right, don't worry about the last one either. Not going to get into that right now. We're mainly going to try to keep it hopefully super basic and simple for right now. So don't worry about doing tangents with numerical values. You should be able to do something like a proof like that, being able to cancel stuff out, but don't worry about using that formula because the algebra with that gets really messy. And then don't worry about that proof at the end, okay? Or finding the exact value. All right, so that kind of gives you the sum and difference formulas and also doing a couple proofs with that. And that's all.